But I'm David Dickinson, freelance science writer. I've written for about a decade with Universe Today and about half a decade with Sky and Telescope. I had a blog for a while at AstroGuys with a Z, and now I tweet at AstroGuys with a Z still. Kind of almost micro blogging. Actually, Twitter is where I'm most active on social media. I'm on all the things, but so Twitter I find is really kind of my platform of choice. And I will say I have to actually work sometimes, so I can't stand social media all the time. All right, a little background before I get into the current book that came out last week. I've worked with Fraser Cain over at Universe Today for about half a decade, and we've been kind of kicking around the idea of doing a book that a basic explanation book of what's actually in the sky tonight. Now, I would say it took us actually 3 books to get that right. The first book was kind of a electronic PDF book we did for a guide to 2017 astronomy. And that guide was kind of in line with the 2017 total solar eclipse. So we went through and did everything that was going on that year, and we kind of interspersed it with some other fun facts and trivia. But then we actually did in 2018, our very first book, the Universe Today Ultimate Guide to Observing the Cosmos. Now this was, they always say when you write your first book, write it as if you're never going to write another book again, because some authors write one book and they say that's enough. That's enough of a torment, or enough of I've done it and I've been there. So I put everything into this book that I know in astronomy, basically compressed into, of course, 200 pages. Now, when you talk amateur astronomy, you're talking observing satellites, solar observing, planetary observing, deep sky observing. You have to run through how to pick a telescope, what telescope is the best telescope. There's, in astronomy, there is a lot of subfields, and we wanted to throw in some activities. However, I was never completely happy with, we had to do the sky season by season, and we went, that's Northern Hemisphere, Southern Hemisphere, covering all the best objects in the sky and all the deep sky objects. And we had to familiarize people with altitude and azimuth and right ascension declination in magnitude and go through. And that's a lot to get somebody up and running and put it all into one book. And the charts on the first book, of course, were for each season: spring, summer, winter, fall, Northern Hemisphere, Southern Hemisphere. Not really, it's usable out in the field, but I was not quite, this is a good coffee table book. We had a lot of excellent astrophotographers contribute to it. There's an excellent chapter on astrophotography, how to get, we wanted to get people into, again, any of these chapters in this book could have been a book. So we wanted to get everybody in astrophotography up to the point of going from shooting bright objects like the moon and the planets and doing star trails and the very basic things you're going to do in astrophotography, getting them to the beginning of deep sky astrophotography. That's usually the biggest hurdle, to start shooting fainter objects and doing image stacking and doing those sorts of things. So again, to go further into that would have been an entirely new book. I dabble in astrophotography. I'm more of a visual observer myself. I like to say I know some really amazing astrophotographers, but I'm a mere mortal astrophotographer. Now, for the second book, or the book 2.5, we decided that we wanted to go from the basic question of what's in the sky tonight and do an actual field guide. Now, you're doing, like I said, good coffee table book, not so much something you want to use out in the field. This one is a little more black and white. There are some, we had some illustrations, and, you know, think back to one of my favorite books that's kind of out of date now, but is legendary among amateur astronomers, Burnham's Celestial Field Guide, or Burnham's Celestial Handbook. This book was written back in the 60s. It has 1950 coordinates. I mean, but it's still, it's a very exhaustive constellation by constellation look at the sky. Not a lot of charts. There's some fine field finder charts, but you can kind of see the text of the day. This is still one of the few desk guides that there's not a good electronic backup to this kind of book out there. So I actually put in, you know, I wanted to kind of do something like this, updated with a lot of in-depth sky charts. Think of this book that we did. The first half of it covers the sky month by month, Northern Hemisphere and Southern Hemisphere. So you have 24 sections, 12 by 2, for the Northern Hemisphere, Southern Hemisphere. The first half of the book covers when you're out and looking at the evening sky in July. What directions are you looking versus the ecliptic plane of the solar system versus the Milky Way galaxy? What are you seeing out there naked eye? And then I wanted to go into some of the mythology of the sky. We didn't get to do a lot of mythology, but I think that's really a fascinating part where you get into history, psychology, and art a little bit in astronomy, because there is an art component to the science of astronomy. You know, they'll say, why study mythology? And I say, well, mythology, when you look through history, you're looking at, you know, who was king when, what battle happened when. But when you look at mythology, you're kind of seeing the psychology of how people thought. You know, where did they think their place in the universe was? What were the stories they told to each other? And I really think that's one of the more beautiful parts of astronomy. And I wanted to try to do, I made a concerted effort. Of course, all the constellations, once the International Astronomical Union in 1922, which we're coming up in a couple of years, just on a century, they actually divided off the 88 constellations in the sky. They actually went, and most of the northern constellations, because we had used them since antiquity with the Greeks, became Greek constellations. I always like to say we have Roman planets with Arabic stars that make up Greek constellations. So that's kind of like shows the history of how astronomy, the southern constellations, most of them that got codified by the IAU were named by someone called Nicolas Lecal back in the 18th century. I may be saying his name wrong, French astronomer. He probably was one, I've heard an amateur astronomer at a star party in Australia once describe him as one of the more unimaginative people in the world, because he named a lot of constellations in the Southern Hemisphere after, they apparently were very proud of their inventions of the day. So you have Fornax, the furnace, you have Microscopium, the microscope, Telescopium, the telescope, but you don't have a lot of the beautiful tales and stories in the modern southern sky. Now, of course, people that had lived in the Southern Hemisphere all this time in New Zealand and Australia that were there well before the Europeans came, they had their own stories and tales that they told about their own constellations. So I thought it was interesting, and I learned a lot actually digging through and finding some of these myths. Really in the Southern Hemisphere, we were able to bring out, so we have a good representation. Again, you couldn't do, it would be another book to do all the mythology of the sky, to do an exhaustive guide, but I think we sprinkled in some really fascinating tales for the Northern Hemisphere for every month, Southern Hemisphere for every month. And if you ever get a chance to go in the Southern Hemisphere, I highly recommend it. If, as a Northern observer, I've been down there 6 times. Like I said before, like to hunt down, sometimes I'm backpacking, sometimes astronomy is not the reason I'm going there, so I can't bring a telescope. But my strategy then is to find a local astronomy group and have them show you around the sky. They love to talk about, and they know the southern sky better than, you know, every northern observer wants to see the large and small Magellanic Clouds. Those are the satellite galaxies you can only see far from the southern hemisphere. You want to see things like the Coalsack Nebula and the Southern Cross and Alpha Centauri, the closest star system to us, and Omega Centauri. And I actually tell people, you know, in the case of Omega Centauri on the top of the Southern Cross, you can see them from Florida, say from northern latitudes, like about 30 degrees north around late April. We actually talk about that a little bit in here, about how to pick off some of the southern targets from up north. And if you're a northern observer, we talk about there are northern objects that people that have lived in Australia their whole life have never seen. I remember one friend of mine in Australia said that he had a hard time finding the Big Dipper because it was larger than he thought. He was kind of thrown off by its scale at first, the very first time he went up north. So I think it's kind of interesting that, and it's interesting in the Southern Hemisphere to look up north and see familiar constellations like Orion in Leo, only upside down. As a northern observer, that was something that was interesting, because you don't see a completely different sky down there. You see some of the sky you're familiar with. So I thought that was interesting. The second part of the book, we wanted to get an actual telescopic object. So we divided it off into naked eye sky with all sky views. Each section, of course, has and there's a reason we did black on white for these kind of charts. And we included some images where we could have objects that we're talking about. We did black constellations and black stars on a white background. these are good to, this guide is meant to be used at the eyepiece of a telescope when you're out there. We actually were testing these, the beta version of this at Star Parties. We were actually out there with our red light and trying to see on the early printouts in the beta versions of these to say, are these usable in the field? Is this something? And you'll notice on each chart, we put along the meridian, because that's the best place you want to observe, is where things are passing right overhead. These numbers here correlate to, when you get toward the end, we have actual star charts where we broke down the sky. This is where we get into telescopic objects. In the second half of the book, there are 20 panels from northern hemisphere to southern hemisphere. The northern hemisphere goes 90 degrees down to 60 degrees declination. And then we have mid-sky charts that go 60 to 20 and then so forth all the way down through. And we made all these charts with the best objects in mind on them. And they correlate, so you can go quickly and say, I'm out here at May 15th at 10 p.m. Northern Hemisphere looking up. Okay, I go to chart 5, and that's going to show me where those best objects are. Now for best objects, our thinking is, of course, we didn't have 3 volumes to do this in like Burnham's or a lot of guides. So we decided to break down the best objects down to 10th magnitude, which is down to about what you're going to see with a small to large telescope, down to 10th magnitude in brightness, which would cover all the Messier objects in Charles Messier's Deep Sky catalog and some of the brighter NGCs. And we did double stars that were, again, we did best stars. We didn't want to do a laundry list of really tough objects. However, of course, we do some quick challenge objects, like have you ever seen a quasar before? There is actually a quasar in Virgo that's at 14th magnitude that, you know, is kind of a cool little object to look at, just to say I've checked off a quasar off my observing life list. We did double stars that are wider than 1 arc second and brighter than 10th magnitude, where both components are brighter. We did variable stars. Again, we did best of, we did Myra, we did Algol, we did some of the very best of variable stars that kind of get you started into variable star observing. And again, we threw in some challenge objects, and we went through and did NGCs. And, you know, basically it's like a star party in a book is how we thought of this. Is something that it goes through in the very beginning. Again, we had to give the run through of how to find your way around the sky, making sense of the sky, directions, you know, where you have the idea of altitude, azimuth, right ascension, declination. But this one, we wanted to go to do actually a little bit of, you know, a lot of the questions we get at star parties are based on what I call the wow factor in astronomy. You know, when you're looking at something like, say, a 14th magnitude quasar, it looks like a little star. Or if you're looking at Pluto, you know, we don't cover solar system. This book is only deep sky objects. But if you're looking at a 14th magnitude quasar, it looks just like a little tiny faint star. But to know that is something that is intrinsically very bright, billions of light years away, and you're looking back in that scale of time. We actually do a table in here too that we talk about the scale of, when you're looking back at Vega, you're looking at, like, you know, back in the 90s, how it looks 25 light years away. When you're looking at the Orion Nebula, you're looking about 1,000 light years away. When you look at some of these objects, you're looking back, say, when you're looking at something like a quasar that's 1 billion light years away, think about the light you're seeing there. There wasn't humans here yet at that time. You know, you're looking back at something that is immensely old. So part of that wow factor, we wanted to describe a little bit about the basic astrophysics, you know, the lives of stars, how we know how far stars are away, what parallax is, what Cepheid variables are, that goes into the cosmic yardstick, where the basic understanding that we have right now, the kind of questions you get. Again, I'm not a professional astronomer. I'm somebody that, my background is in earth science teaching, and I'm just somebody that reads a lot about astronomy and writes a lot about it. I'm learning something new every day. And one of my challenges when I go out and observe, no one will ever see everything there is in the sky. I always try to see something new, whether it be, you know, we just had a big bright comet. That was kind of cool to watch. I actually used this to plot its position on one of the charts. You can do that with these pages. I'd say water resistant. They're not waterproof, but they're bound in spiral, and they're waterproof, so you can actually use it to just kind of plot like the location of objects. I see a few questions coming in, but I will take questions in about 10 minutes. I'll get done with the book. I'll do them in batch. Because one thing that happens when you're out observing at night, things cool down, dew starts collecting. In any other book I've had, you don't want to have a book like that out there in the field. It starts getting wet as it sits out there. And you want it spiral bound, so you can just have this like plop down on a table. We pushed the publisher to actually do that. We said, if we want something that people are going to use out there, as opposed to using something that's bound like this, again, beautiful book, but the problem is when you have it lay flat, the pages want to close. You want something that you don't have to clip it open or anything like that. So I'm going to read some very quick sections from the book here. I am going to bring it in at half an hour. Just to give you an idea of what I was talking about as far as the very basic premise of the book. Part of the fun of stargazing, this is from the Wow Factor Astrophysics 101. Part of the fun of stargazing is knowing just what you're seeing. Sure, a star is a point of light, but to know that star is another sun, much more massive than our own, is to realize that you're just one wonderful facet of the universe we inhabit. But the deep sky does not give up its secrets easily. One of the most common questions I hear at a star party is, what is that? The question is also followed by the more common question of that is much more difficult to answer. How do we know that? For example, it always amazes me how much we take for granted in the following information. The stars are suns, but they're far away. The sun is a star, the closest one to the Earth. Nebulae are star-forming regions, places where gas and dust are collapsing and just starting to shine via nuclear fusion. The sun is about midway through its 10 billion year lifespan. The sun is just one of billions of stars orbiting our Milky Way galaxy. Our galaxy is littered with hundreds of star clusters, some tight and densely packed, some loose and open. It is also cluttered with planetary nebulae, the leftover corpses of dead stars, to include white dwarfs, pulsars, and black holes. A massive black hole known as Sagittarius A, pronounced A star, lurks at our galaxy's center. The universe in turn contains billions of galaxies and got its start 13.8 billion years ago during the Big Bang. That's a lot to take in for sure. And I always tell people that that's kind of our modern understanding of where we are in the universe, in time and space, in something that's a little longer than maybe 2 or 3 tweets. But that's something that took us thousands of years to come to that conceptualization to understand. And just with those, how old the universe is and where the Milky Way is, and to break all that down, how we know that is to go through and describe the entire history of modern astrophysics to that point. But here you have it on a page, something you can break down. That's like your kind of standard spiel that you can give out to people at a star party, our standard thing. And it's always funny, some of the things that, there's things that are still being tweaked out there that I'm like, I have to change my whole spiel now. Like we used to say that, some of the most stars you see up there are multiple stars. Me and Fraser actually went around on that. He's like, there's a study out there that shows that most stars out there are actually not multiple, they're solitary. And I'm like, it's like, I had been saying that for years, and I say, well, I could actually modify that to say most of the naked eye stars you see out there are multiple stars and not solitary like our sun. But that we're still discovering things every day. And as I'm writing and reading about astronomy, there are new things that are coming up. I'm going to read you a very brief section from we just passed July. You can use some of these charts. You notice I actually put the timing in here. So the sky is slowly shifting. So even though it's early August, this July 31st chart at 9 p.m. right after local sunset here, these are done incidentally for latitude 35 degrees north and south. Now, if you're at latitude 40 north, it's still pretty accurate. That's where a majority of the Earth's population lives, within about 10 degrees either side of 35 north up to 45 to 35 south, or 25 south. So the sky at Scorpius hour, Scorpius being a constellation right along the meridian, The northern July sky. If, like many residents in the northern hemisphere, you find yourself camping in mid-July, be sure to take the opportunity to check out the night sky from a dark sky site. Two key points in the sky give the observer a perspective of our place and direction in the Milky Way galaxy. The first is the direction we're headed, along with our sun and the rest of the solar system, known as the solar apex. This was first discovered by William Herschel in 1783 during an early survey of the proper motion of nearby stars. Herschel placed the solar apex near the star Omicron Herculis in the constellation Hercules. This is not a bad guess considering the modern estimation places it just across the border of Hercules in the constellation Lyra. This direction is located very near the zenith, zenith being straight overhead, on July evenings about 20 degrees above the galactic plane. We take about 250 million years to complete one revolution around our Milky Way galaxy, and the Earth and our solar system has completed this trip about 18 times since our formation from the solar nebula a little over 4.5 billion years ago. Something I like to do, and it's something you can point out with no telescope needed, is just to point up into that direction of the zenith in July in the constellation Lyra, very near Omicron Herculis, and say, we know that our whole solar system is moving off in that direction, along with all the other stars you see around you that are naked eye stars are all part of the Milky Way, and we're all moving in that 250 million year orbit. Now think about a 250 million year orbit means that one orbit ago, again, there weren't humans here. That kind of blows my mind, and to think 250 million years from now, what is going to be, the Earth will be here, the sun will still be here. Humans might be here, we'll see, but it's just kind of gives you that perspective in space and time. No instrument or telescope needed, just stand out on a clear night and look up. Here's something that's very brief also on July star lore that I thought was kind of interesting. Every culture has its own myths as to what the dusky summertime plane of the Milky Way really is. The Peruvian Incas had a unique set of constellations shaped around the Milky Way. They saw shapes not in the patterns of stars, but in the dark lanes carved out by gas and dust. In this schema, the negative dark spaces of the Milky Way became shadows of llamas and foxes. I actually managed to include a photo from the Cusco Museum in Peru of this very same concept. Something I think that was kind of unique, that always struck me with the Peruvian Incas, because most peoples around the world, the Greeks included, saw the stick patterns of the familiar stick patterns of Orion and the Big Dipper. But however, from Peru, right there on the equator, they're looking at the Milky Way where they're seeing these dark lanes, and they had no idea that this is dust and gas that's obscuring the stars beyond. To them, their constellations were those shadow outlines that they saw as the shadows of people and animals moving along the plane of the Milky Way. I just thought that's kind of a unique way to, a different kind of perspective to look at. You think from a perspective of something straight out of art class, where you're looking at the negative spaces instead of the bright filled in spaces, and those are actually your constellations. Let's see, that's pretty much it. As far as the book is littered with all kinds of little factoids, tidbits, interspersed with each section. As far as we couldn't do a deep dive on every object, but we did do a lot of tables that were kind of fun to do. Broke down all the constellations, again, cross-referenced with where they're at, all the Messier objects, so you have a quick list reference back here. If you want to know where the Little Dumbbell Nebula is, Messier object 76, you can flip right back to panel 2, and it will actually show you exactly, so the book was, we put a lot of work in mind with all the cross-referencing, so you literally can quick flip back and forth. One page, of course, you're going to want to reference a lot. I would even marker it. This is the key, the beginning of the second page, the second section that has the Northern Hemisphere all sky charts, again, down from from Polaris in the Northern Hemisphere, from chart 1 all the way down to the southern celestial pole on chart 20. So, and these are all listed up from 1, 2, 3, all the way down around. This page you'll find yourself going back and forth to a lot in order to go up to the other charts. But again, we spent a lot of time cross-referencing these. So it's, that's the book. And if there's any questions now, I think I can, I saw some going by real quick.
Yeah, looks like we have quite a few here. So I'll just
Okay.
remind everybody we have the chat feature on the right-hand side, and at the very bottom there's a Q&A. So go ahead and get your questions in, and then we'll ask our speaker here. So we'll start it off here with Gary, and he asks, where can you get away from light pollution in Northeast Ohio? And I'm sure that's applicable anywhere that has a big city, because you're actually from Virginia, but where's a good way to sort of get away
Yeah,
from light pollution?
the East Coast is really difficult. If you have an astronomy club, most of the time they know where all the little secret dark watering holes are. Like I'm still finding even around here, we're right on the center of the East Coast, and I observe, especially with the quarantine going on right now. I'm in an apartment in downtown Norfolk, and we have an open parking garage. I always like to say your observatory is where you are. And I've observed from some very dark sites, like I was at the Nebraska Star Party a couple years ago, which was like a pristine dark sky out in western Nebraska. And here in downtown Norfolk, we're down to about third magnitude, which is maybe the brightest stars in the sky. I go up on our parking garage rooftop here and observe because it's open to the sky and it's kind of secluded and quiet up there. But sometimes I've observed from, again, really dark sites in Morocco, and I've observed from the strip in Las Vegas. I've shown people stuff which is maybe arguably the most light polluted place in the sky. So I would find, if you're looking for somewhere nearby, find some people that are experienced with the area. Usually they're in astronomy clubs, and they usually know where they have their places they go for public parties, and then they have their places they go to do serious imaging. Like the guys here in Norfolk, they go down to the Outer Banks in North Carolina, and they've been talking about there's some darker areas that are really close by.
Okay, great. So next question we have from Jay Butler, and he asks, where do I find a star party in our area? Where do you find one at?
Well, a lot of them are shut down right now. If you start Googling around, Sky and Telescope, I know has a list of, on their site, they have a list of astronomy clubs, and that's usually the first place you start is what clubs are there in the area. And then you'll find out exactly most of those clubs. The one here we have in Norfolk, we're generally pretty active. Again, public star parties are things are kind of opening patchwork right now, with some places are still under quarantine and some aren't. The club here just started doing small star parties a few weeks ago in Virginia, but I think with the latest order from the governor, that might be getting curtailed. I haven't heard from them yet. So yeah, just look around. I know Sky and Telescope has a fairly updated list of star parties on their, or clubs. You go from clubs, and then clubs will be doing star parties, of course.
Okay, great. William asks, what should you look for when buying a beginning backyard telescope? Features and specs.
Well, I always tell people to learn the naked eye sky first. And then once you've done that, I mean, this is a good book for that. Once you've done that, binoculars, I find myself using binoculars about 90% of the time. I have several telescopes. Actually, this one, I wish it was mine. I'm reviewing it right now. You know, it depends what you want to do too. I mean, starting out, you can't go wrong with a good Newtonian type telescope. I always tell people on a Dobsonian base. The Dobsonian base is an alt-az base. It rotates, it goes up and down. It has, you want as big a mirror as possible. It's going to show you more stuff. It's like most of the time when you hear amateur astronomers talk tech to each other, they're talking about the aperture of their mirror more than magnification. A lot of telescopes are advertised with high magnification, but really you're actually most of the time going to be using, like, you know, if you see something advertising 1000x magnification, you're rarely going to want to use that kind of, the problem is when you magnify something, you're also shrinking your field of view. So if you hold up something like a little tube of a pin up to the sky and just look through that and try to find something, that's about the equivalent of what you're trying to do with the telescope. You want a bigger field of view. That's going to give you a much more, like something about the size of a full moon, which is half a degree or bigger even. I've had some telescopes. I had a 10-inch Schmidt Newtonian that it had a field of view about 2 degrees, which is 4 times wider than the full moon. But you want that generous field of view to kind of sweep around and actually find objects. And you got to think too, when you're getting a telescope, what you might want to do long term. If you want to do mostly visual, a Dobsonian is something, just get as big a mirror as you can, and something really simple you can push around. If you think you want to get into astrophotography, that's going to mean something on a tracking mount. And a tracking mount is something that you have one axis aimed at the North Pole, and it's either on what's called a German equatorial, where you have two poles like this and it rotates, or it's on a fork mount that's tilted back and it rotates. The key is this follows the sky as or if you're doing any kind of live broadcasting or anything, or you're just doing image stacking. If you're going to do any kind of imaging, you want to invest in probably the mounts are overlooked, but if you have a wobbly mount, you're going to be really frustrated with trying to aim it. If you really, a lot of amateurs go the other way and have these huge rock solid steady mounts, but you can spend more on a mount than a telescope, actually, just getting something that, and computer driven, this one, of course, is smartphone controlled, but I use telescopes where I just push them around and aim them. Computer go-tos have their place, but learn your way around the sky first. And, sometimes go-tos, you may spend more time troubleshooting a bulky mount and trying to just figure out. I always say, there's a problem when your telescope's pointing at the ground, that it's probably not looking at the right. But I think everybody who's at a go-to mount has had that experience where their telescope pointed at the ground for them when you tried to find something. So learn your way around the sky and then get a telescope.
That sounds like pretty good advice. So Barbara asks, can your book be used as a reference anywhere in the world or just the United States?
No, it's based on northern southern latitude. Like I said, 35 degrees north, but you could use that on 35 degrees north and south is where I based the charts where you go month by month. But you could use that about 10 degrees on either side of that and still be pretty close to accurate. So maybe not at the poles, but not many people go to the North or South Pole to use an astronomy book. But I'd say that covers, and I think I mentioned in there, and I actually calculated this, it covers about 80% of the Earth's population. It's surprising how and I actually looked at a website where they looked at the distribution of population by latitude. And it's interesting to think that most of humanity actually lives on those belts between about 45 degrees north, 45 degrees south. There's that covers from, say, 45 degrees north, just off the top of my head, I think that's like northern Maine. That covers the continental US down to, I believe, like Tasmania, and so that would cover all of South Africa. This is me not looking at a map, but it would cover all of. I know New Zealand is a little farther south, but then when you get to Tasmania in South Africa and most of South America, that southern tip of Tierra del Fuego probably goes down there a little ways. But I'd say you could use it in about 80%, 90% of the world.
Okay. We have one from Gary, and he asks, what do you think of apps like Star Tracker? Are those good?
Star Tracker, I haven't used those. I use one called Heavens Above for satellite tracking. There are so many astronomy apps out there. I haven't tried all of them. Star Tracker, I have not heard of. That sounds, I don't know if that sounds like might be a plate solver program. I know there are some now that you can actually hook your smartphone to your telescope. Celestron's doing that. I think that sounds like that, but I haven't reviewed it myself. Heavens Above I use for satellite tracking. That's really good. A friend of mine in India did one called Cosmic Watch, and of course, Google Maps has their own version of planetarium apps out there. So I'm using another one I use. There's one that's clear outside that I use just to plan my observing, just to see. It gives you more of a weather meteorological discussion of what's going on based from an amateur astronomer's perspective, I'd say. Basically looking at what the seeing transparency in the cloud cover is going to be over the next 24 hours. And this all works off your phone's GPS. So. And Stellarium, I saw somebody just mention, yes, that's one I use. I think they have an app for the phone now, but I use a Stellarium on my laptop. A lot of these templates were actually made before I started, the reference templates I used before I started doing these in Adobe Illustrator and kind of teaching myself Adobe Illustrator were done in Stellarium originally. It's a great free app program that's out there. I have it on my desktop and I'm looking at it nearly every day.
Okay, great. So we have an interesting question from Jessica, and she asks, do you have any tips to keep children and teenagers engaged in astronomy, whether it's websites or just looking up on the skies? Can you think of any way to sort of get them interested in astronomy and stargazing?
Yeah, it's, you know, everybody's always fascinated with the first time they look at, say, Saturn or a planet. Um, it really depends on some people, you know, things like the mythology and the stories of the sky resonate more. Some people are more fascinated with the telescopes I see out there at a star party than looking at the actual sky. Some people are more interested, you know, I always look at what kind of satellite passes we have that night. And if there's a pass of the International Space Station, again, we don't even look at that through a telescope. We just look up and see the International Space Station passing over. And I've had people, when I used to do public outreach at the Flandreau, we would step outside the dome and look at that sort of thing. And they were more impressed with that than anything I could show them through the telescope. So it depends on your object or your audience. As far as when I've taught students, I've actually given them a homework assignment if I knew there was going to be a pass of the ISS that week, of going home and, you know, with an adult, go out and try to find the International Space Station at a certain time if it's clear that night. And that's always, I think, an easy way to engage people.
Okay, great. So Gary has a question. You mentioned binoculars earlier. Do you have any recommendations for any of those? Like, what should you get?
You know, a good pair of what they call 7x50s, which you might have just lying around. They're used for hunters use them, bird watchers use them. Those are pretty good. Now, when I say 7x50, what I'm talking about is there's basically two numbers that describe a pair of binoculars. The first number is how much magnification the diopters, the eyepieces have. The second number is the aperture size. That's your light collecting area. So those are magnified 7 times and has 50 millimeter aperture on them. That's a pretty standard hand carried pair of binoculars. I have a pair that's a little more advanced. They're kind of over there in my stash right now, but they are a pair of image stabilized binoculars. They are not cheap. Canon makes these. Mine are 15x45s. And the key with those, they're battery powered. I've got these about 20 years ago. They use the same kind of video stabilization technology that is common with video cameras. When you hold the button down on the side, it cancels out the natural hand jitter you have from holding up binoculars. So instead of the image like shaking as you're looking at it, it kind of floats there. So you can see more detail. Again, they're not cheap. If you look through a pair of these, you may never want to buy a normal pair of binoculars, but you know, a good pair of 7x50s, Celestron makes them, Meade makes them, most every optical company makes them. They're, you know, you can get a good pair for about $100. And I still, to this day, sometimes if I just want to take a quick look at something, you know, binoculars have no setup to them. You just hop outside and take a look. So if I just want to go out for 10 minutes and observe, I just throw my binoculars over my shoulder. Or again, if you're hiking or you're traveling somewhere remote and you don't want to lug a lot of gear, I've hiked in New Zealand and just brought a pair of binoculars with me. And it's because I couldn't tow a telescope with me in a backpack. So.
Okay, we have an interesting question from Mike. He says, on the planet, where would be the best place to see the Milky Way galaxy?
I would go down toward the equator because it's right this time of year in July and August in the evening. The Milky Way comes almost right directly overhead. From here, you realize you see it in the summertime when you're from northern. I'm latitude about 35 degrees north. So down toward the constellation Sagittarius and Scorpius, you're looking at the core, but that's kind of down on the southern hemisphere when you're actually looking at it. So I would go down toward the equator, and like right around this time of year, you're looking, you know, in the wintertime, you see part of the Milky Way, and we describe all that with different directions too. When you're looking out in the Orion in the wintertime that's overhead, you're actually looking out away from the core of the galaxy, but a lot of it is obscured by dust, so you don't necessarily see it. You're looking at the Orion, but what's cool, you're looking at the Orion spur in Perseus, that part of the arm, you're looking at the arm that our solar system is actually in. When you're looking in the summertime, you're looking one more arm in toward like the constellation Scutum. And we talk a lot about, I think it's important to get that kind of direction when you're looking at the galaxy and stuff, to try to get that idea of, see if I can find the diagram here real quick. This diagram here, when you're actually looking at, if you could look at our Milky Way from above, this is what we think it would look like. And you're actually looking at our location and our address there versus in the wintertime, you're kind of looking out, and in the summertime, you're looking inward toward the core here. But most of that rides higher up in the sky in the southern hemisphere. And incidentally, being a barred spiral like that, if you were to look at this kind of diagram when I was a kid, even in the 70s, we didn't even realize that our galaxy was a barred spiral like this. This is something that is kind of, newer. Astronomy has changed in my lifetime as far as, our understanding of the age of the universe is getting a little more refined. Our idea of, when you're looking at the Milky Way galaxy, of course, we're like trying to figure out what the forest looks like from being inside near the trees. So it's kind of hard. We can't look from the outside. This kind of picture emerges from, again, it gets into that, well, how do we know this? Somebody asked me at a star party, and you're kind of like, well, we look at different stellar groups that are nearby. We're looking at their proper motions. We're looking at sample populations, and this is getting better. Say the European Space Agency just launched their Gaia mission, and its mission is to look and get the very fine, accurate proper motions and positions and parallaxes of millions of stars. And from that, put it into a computer, and a picture kind of emerges of what this big rotating spiral looks like. All this, of course, from being at that vantage point in the center, not in the center, but our vantage point off to the side.
Okay, we have time for a few more questions. So everybody, if you want to ask questions, don't forget about the Q&A and then our little web chat thing. We have a question from somebody that says, do you consider Pluto a planet?
Well, I can tell you where the International Astronomical Union, do I personally consider Pluto a planet? I know a lot of times people don't want a nuanced answer, but it's a nuanced kind of question. I would say, and again, we don't really talk about the planets much in that. The first book we did, yes, we discussed planetary observing. Pluto was demoted in 2006 by the International Astronomical Union, and its newer status as of 2006 was to be a dwarf planet. Now, the what is a planet is more of a cultural definition than a scientific one, I would maintain. This is my own opinion, because for a time, when they, from Galileo's time, they knew of planets from Mercury. What isn't a planet? For a time when we thought the Earth was the center, the Earth wasn't a planet. The moon and the sun were planets because they were considered going around the Earth. Now, they had no reason to suspect all the way out through Galileo's time, and he first turned his telescope to the sky and recorded what he saw, that there should be more planets out there. They figured out to Saturn was all there was. Actually, Galileo missed discovering Neptune. It passed by Jupiter on several nights, and he sketched it in his notebook. There is actually notebooks, I've seen this in Florence, where at the Scientific Museum, where they know now that those stars that Galileo sketched in the background, running a planetarium program like Stellarium back to those dates, they know that he saw Neptune, but he failed to identify it as a planet. Now, later on, William Herschel discovered Uranus, and try to sum up the whole thing up to Pluto. Later on, they discovered Neptune, but for a time, when they started discovering asteroids, they were added in to the whole solar system series for a time, Vesta, Juno, and they realized that if they started naming all these, there would be hundreds of planets by now, so at that time, Pluto, when they discovered it in the 20th century, it was a planet for a while. But what I'm getting at is what is and isn't a planet. It's more of a cultural definition, but it's always changed. And I think that may still keep changing. One thing I'm interested in, and so, I'm not too upset to call Pluto a dwarf planet right now. I know that kind of irks a lot of people, but I think that definition may keep changing as we start finding out what's out there in the solar system, and out beyond with exoplanets. I think there's going to be another defining line that's going to be blurry when you look at planets that blur the line between Jupiter objects, substellar objects that start doing fusion, and then true stars. I think we're going to find things that are going to blur that too, and then we're going to be looking at, well, is that thing that's 10 Jupiter masses, is that a brown dwarf or is that a planet? So I think we're going to find those these are constructs that our culture puts out there and says these are plants. But, you know, we're going to find, like with everything we categorize in science, that they're not going to necessarily be neatly pigeonholed into those categories. And we're going to have to learn a new mnemonic, as we always had, for how to memorize the planet. So I know that's kind of a convoluted answer to it. But.
Tom asks, your name sounds a little familiar to a gentleman called Terrence Dickinson that wrote a book called
Yes.
The Backyard Astronomer's Guide. Is there any relation?
No relation. I know, actually, I know Alan Dyer and I know Terrence Dyer out there. It's a completely different book. The publisher knows that as well. But originally, we wanted this one to actually be the Backyard Astronomer's Deep Sky Field Guide. So.
Okay. There's somebody that asks, have you ever seen something up in the sky that you couldn't explain, whether it be a planet or a star or something else?
A few times. You know, usually it took a little bit of sleuthing and researching. Probably the thing that stood out, that actually took a few decades before I pinned this down. When I was observing out in Alaska, I actually saw it was right at dusk, and I saw a train of, this is before there were Starlinks or those kind of satellites, but I saw a train of satellites up in orbit, and I saw them wink out and hit the Earth's shadow. There was 5 of them in a row. There was like a bright one that was followed by 4 fainter ones. And I knew it was something up in orbit, and I thought it was either it was something classified or it was something that had fragmented, or it always stuck with me for a while till I asked Ted Mulzican up in Canada, who does a lot of satellite tracking, and I mentioned the date and time and where I was located, and he said, you probably saw there was a launch of Iridium satellites from Vandenberg earlier that afternoon, about half hour before that observation, because I wrote down and kept what the time was and where it was. And so that stood with me for about 20 years, but after, you know, eventually we did figure out, well, I knew it had to be something in orbit, but that's probably one of the stranger things I had seen.
Okay. We have time for a few more questions here. Hopefully some people can get them in. We have one for Mike, and he asks, are exoplanets something that can be viewed or identified by a backyard astronomer?
You know, it's interesting you asked that, because there are actually this company that I'm reviewing the scopes for, Unistellar, this EV scope. This scope works via your smartphone, and it actually has an image sensor in it where you can image and collect data from what it's looking at. And one of their ideas that they're actually doing this now is looking at known exoplanets or suspected exoplanets that other system, you know, things like the Kepler mission or the TESS mission are actually finding. And they can get a light curve from what's called transiting exoplanets. Exoplanets being, when a transiting exoplanet, when one passes in front of a star, it actually dims it by a little bit, but it dims it by a known amount. So when you look at the light curve, you see a tiny little dip in its brightness. And that's how they find these planets, because they're transiting along our line of sight. But this company actually has been observing transiting. I think that is kind of remarkable too, figuring they only found the first exoplanets in the 1990s. So for people to go in, like, from a suburban backyard, be able to actually kind of, it's observing in a sense that you're seeing the dimming of its brightness with it. So I think that's kind of remarkable, but yes.
Okay. I guess last fall for questions, if anybody likes to ask the author there, give you everybody a minute here. Oh, somebody is asking, Jody is asking, what is an exoplanet?
Exoplanet.
I think it's the exoplanet. I think that's probably what you might be asking. Yeah.
Yeah, exoplanets are planets beyond our solar system. And again, we only knew about these since the 90s. When, you know, growing up as a child of the 70s and 80s, I remember reading that some of the best astronomers of the time thought that we may never discover exoplanets. I remember seeing this argument back as late as the 1980s, because they thought they're just simply too faint, too far away. So now we live in an era here, 2020, that I think the tally is up to about 4,200 and counting exoplanets we know. So it's that's been something in our lifetimes that's really been a remarkable, not only have we found planets orbiting other stars, but we know of enough of them that we can start classifying. The big thing we want to know is how normal or weird is our solar system. We want to know, are we an average story? What goes on here at Earth? with, you know, the evolution of life in our solar system and what's happened here, or are we kind of an anomaly? And that question of what other solar systems look like compared to our own just goes a long way toward answering. That's one of the very first parts of the Drake equation, to how common are terrestrial planets. That's something we know now in our lifetime.
Okay, Marisa asks, how do you feel about the fourth dimension, or is there a fourth dimension?
Well, yes, there is a fourth dimension. That's known in physics because that's kind of what when you talk about the expansion of the universe, again, I'm not a physicist, but I know a lot of physicists that you're talking about the expansion of the universe. The natural question is, what's it expanding through? And then you get into kind of fourth dimensional space. So it's a known construct that's out there. You can't point to any physical place in our universe and say, that was the center of the universe, because the Big Bang really kind of, it happened everywhere in a sense, if that makes any, it's nonsensical because we don't deal with these kind of things in our day-to-day lives. We don't deal in a fourth dimension. It's not something we evolved to have to deal with in our day-to-day lives, but we can look out there and mathematically say, and see these observational things of like galaxies expanding away and say, yes, that it's actually a true construct. There's observational evidence for this sort of thing.
Okay. Oh, we have one from Asher that asks, what's the most breathtaking thing you've seen in the sky?
I would give it a three-way tie. Saw the 2017 total solar eclipse, which if you've never seen a total solar eclipse, there's another one in 2024 on April 8th. Make sure you make it. That's going over North America. That is a very remarkable thing to see. I've seen really good Northern Lights shows. That's number two. I lived in Alaska, Northern Maine, and that's pretty remarkable. When in the Northern Lights, unlike an eclipse and you know it's going to happen, Northern Lights can just kind of flare up all of a sudden. And then when you get that really bright shimmering of, you know, yellows and greens, and just like it's really eerie to watch. You get a really good Northern Lights show. And the third one, I would say, I saw the 1998 Leonid meteor storm from Kuwait. I was in the Air Force at the time, and it was super dark out in the desert in Kuwait. And this was a meteor shower that is like a once in a lifetime. They were coming like one every several seconds. You could look up. It wasn't like a meteor shower, like the Perseids are coming up in a few weeks, and they're interesting to watch. But you'll watch for an hour, and maybe you'll see 10 or 12. You would see 10 and 12 from the Leonids in 98 in a minute. I mean, it was literally like they were just coming, like, you know, I've never seen a meteor shower quite that active. That was very impressive.
Okay, our final question has to do with the moon. We sort of talked about that kind of with planetoids and things, but there's a question that somebody wants to know: is it a planet? Is it a planetoid? What do you think? A satellite? What is the moon, in your opinion, more like, a planetoid or a satellite?
The moon is the only natural satellite of the Earth. It's probably the most, and it's really fortunate we have a large moon. In a way, it gave us something to kind of, you know, scientifically. It gave Newton probably the most insight he had into how gravitational theory worked, you know, and it gave us a lot of, you know, it's the only astronomical object when you look at it, you see, even with the small pair of binoculars or telescope, you see something that looks like a world. You see craters and mountains and shadows. And it's, I've known people that are content with just scanning the moon with their binoculars. That always amazes them. So it's the natural satellite of the Earth is the easiest way to describe it.
Okay, great. Well, thanks again for everybody coming out, and thanks again for you, David, for talking about the wonderful backyard astronomy. It's going to be great. I know I'm going to be looking up there maybe after the hurricane, because it doesn't look too good. But thanks again for coming out, and don't forget, everyone, there's the link there if you wanted to click on it, the Learned Owl, the learnedowl.com if you wanted to buy autographed books there. And again, thank you so much for coming out, David. We really appreciate your talk. It's very interesting.
Thank you.
Okay, thanks everyone.